Today we are going to be learning about similar polygons. So our learning target is how can I use proportions to identify similar polygons? Key terms: similar polygons. Corresponding angles are congruent, so the same. Corresponding side lengths are proportional. So we're going to be using proportions. Scale factor is the ratio of the lengths of the corresponding sides of similar figures. Similarity statement. All right, so if we look at these two triangles, triangle ABC and triangle LMN. Well, if we notice, we have congruent angles. There are 3 pairs of congruent angles. That's one piece of similar figures, congruent angles. The other piece is proportional sides. So if we look at side AB, that would correspond to side LM. So 5 to 10, that would be the ratio of the side lengths. Then if we look here, BC and MN, 3/6. Is that a true statement? Well, yes, it is, because 5/10 reduces to 1/2, and so does 3/6. We can check with the last side length, 6 and 12. Well, we can add that along with the other two fractions because 6/12 also reduces to 1/2. So 1/2 would be our scale factor. So it would have a scale factor of 1/2. And we could say that ABC, triangle ABC, is similar to triangle LMN. Again, just like when we were working with congruent, we would write it in the order that they are congruent. Angle A is congruent to angle L, angle B is congruent to angle M, and angle C is congruent to angle N. We use this symbol, just one squiggly mark, to indicate similar. Example 1, using the image to the right, find x. Well, our image to the right tells us that triangle DEF is congruent to triangle MNP. So we know that D and M are going to be congruent angles. We know that E and N are also going to be congruent angles. And we know that F and P are going to be congruent. All right, so now we just need to find x. Well, x is a side length, so we need to set up a proportion of corresponding sides. 9 and 12 correspond, so we can say 9/12 is equal to x and 20 correspond, so x/20. Solve your proportion using cross multiplication. 12 times x is 12x equals 9 times 20, which is 180. Divide both sides by 12 to get x all by itself. We get x equals 180 divided by 12 is 15. So x would be 15. Example 2. In the diagram, ABCD is similar to QRST. First question is, what is the scale factor of QRST to ABCD? Well, we just need to find one corresponding side. So we want from QRST to ABCD. So we want to start with a side length from QRST. Well, let's just take QR. right there, 6. And the corresponding side length is AB, so that would be right here, 12. So the scale factor would be 6 to 12. We could also write that as 6 over 12, which reduces to 1/2. So the scale factor would be 1/2. Now we want to find the value of x. Find the value of x. Well, since we have our scale factor, we can use that to help us set up a proportion. We know that the scale from QRST to ABCD is 1/2. So let's pick the side x, because that's what we want to find, BC. And that's going to go on the bottom because it's part of ABCD. Then on the top, we need the corresponding piece to x, which would be RS. So we would put 4 on top. Solve for x using cross multiplication. X equals 8. Perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to or proportional to the ratios of their corresponding side lengths. So in our example, we could say that the perimeter of the red polygon over the perimeter of the blue polygon, that would be the ratio of the perimeters, is equal to the ratios of their corresponding side lengths. So if we pick a corresponding side length, we could say KN and PS. As long as we knew what KN and PS were, we could set up that proportion and it would be true. So in example 3, we're going to use this theorem. In the diagram, ABCDE is similar to FGHJK. So we're given two similar figures, ABCDE and FGHJK. First thing we want to do is find the scale factor of FGHJK to ABCDE. So we want to know what's the scale factor. Pick two sides. Well, let's start with our smaller figure here. We only have two side lengths, x and 10, so we need to use 10, which is AB. So the corresponding piece to AB would be FG. So we're looking at FG. 15 over 10 would be the scale factor, which we can reduce to 3 over 2. That would be our scale factor. Second question. Find the value of x. To do so, we need to set up a proportion using our scale factor, 3 over 2, equals the value of x goes on the bottom, because remember, we were working with the bigger figure, the ratio of the bigger figure to the smaller figure. So that ratio is 3 to 2. X is on the smaller figure, so it needs to go on the bottom. We need the corresponding side to AE, which would be FK. That is 18. Solve for x by using cross multiplication. We get 3x equals 2 times 18, which is 36. Divide both sides by 3 to get x all by itself. X equals 12. Last question. Find the perimeter of ABCDE. Well, we know that the perimeter, the ratio of the perimeters of the big to the small is going to be equal to the scale factor. It's going to be equal to the ratio of the sides. Well, we know the ratio of the sides is the scale factor, 3 to 2. All right, so all we need to do is find the perimeter of the big figure and the perimeter of the small figure. Well, we're looking for the perimeter of the small figure. That's what we want to know because we don't have all the side lengths. We're missing a couple. However, on the big figure, we have all of the side lengths. To find the perimeter, we add them up. We do 18 plus 15 plus 9 plus 12 plus 15. When we do that addition, we get that the perimeter of the big figure is 69. So in my proportion, I'm going to put 69 for the big figure. The perimeter of the small figure, I'm not for sure, so I'm going to leave that as my variable, is equal to the ratio of the sides. It's equal to that scale factor, 3 over 2. We can solve for the perimeter of the small figure by using cross multiplication. 69 times 2 is 138 equals 3 times the perimeter of the small figure. Divide both sides by 3 to figure out what that perimeter is. We get the perimeter of the small figure is equal to 138 divided by 3, which is 46. So that would be the perimeter of A, B, C, D, E. 46. Last piece, similarity and congruence. This is just stating that any two congruent figures are also similar figures because their ratio of sides would be congruent. They would have a ratio of 1 to 1. So any congruent figures will also be similar. However, similar figures will not always be congruent. Corresponding lengths in similar polygons. So if two polygons are similar, if we have two similar polygons, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor. That's saying that if we had two similar triangles, the medians would be equal. The ratio of the medians would be equal to the scale factor. The ratio of the altitudes would be equal to the scale factor. The ratio of the perpendicular bisectors would be equal to the scale factor. So it's not just side lengths that are equal to the scale factor in similar polygons. It's also any other corresponding length. So if we look at our example, number 4, in the diagram, triangle JKL is similar to triangle EFG. Find the length of the median KM. Median KM. So KM is right here. We want to know what that length is, so I'm going to assign it a variable x. Now, we're given this piece, JM is 48. And that would correspond with GH, which is 40. So we can say the ratio of 48 to 40 is equal to the ratio of median KM, which is x, and this median right here, HF. We can solve this using cross multiplication. We get 40x equals 48 times 35, which is 1,680. Divide both sides by 40 to get x by itself, and we get x equals 42. That's all the notes that I have for you today. Thank you for watching the video, and please subscribe to my YouTube channel.